In this video, we're going to use the total derivative to derive the utility maximizing condition. We have a function z that is a function of variable x and variable y, where y is a function of x. Variable x affects z directly and indirectly through its effect on y. The total derivative is going to be defined as follows, where the direct effect is this partial derivative of function z with respect to x, and the indirect effect is everything else. We can derive the total derivative by taking the total differential of this function. So here's the total differential. Now we're just going to divide both sides by change in x, or dx. And this term right here, dx over dx, is just 1. And that is our total derivative result. Now let's apply this to our utility maximization problem. So utility is a function of units of good x and good y. And we have the consumer's budget constraint. And if we solve the consumer's budget constraint for y, we see that y is a function of x. And notice here, if we were to take the derivative of this equation on top here, with respect to x, we get minus the price of good x divided by the price of good y. So let's take the total differential like we did previously. So the total differential will break down like this. Now if we divide both sides through by dx, recognizing that dx over dx is 1, and for maximization we're just going to set this result equal to 0. So we get this result here, and we found the derivative of y with respect to x is minus the price of good x over the price of good y, so I'm going to make a substitution for this derivative result right here. Moving on. So just rewriting our last result, and now moving some things around. Dividing through by the partial derivative of the utility function with respect to y. And on the left-hand side, we got the marginal utility of good x divided by the marginal utility of good y equals a ratio of prices, the utility maximizing condition, which just simplifies down to the marginal rate of substitution equals the price of good x divided by the price of good y. Okay, that's it.